Good afternoon, everybody. Here I have another video on transformations. This is one specifically for sine, and it's involves one of the more complicated transformations. There's just more work involved. If you notice here, the equation here, you have the number 5. So there's an amplitude of 5. So that means your high point is 5 and your low point is -5. The coefficient of the t represents the angle. This is going to tell you how your period is going to change. Since the sine function recycles itself every 2 pi, you take 2 pi and you divide it by 2. And so now the length of your period is going to be pi. So when you have this number here of 2, what happens here, the transformation or the change is your period is going to shrink. Then there's minus pi over 2, which is a horizontal shift, pi over 2 to the right. So we have 3 transformations over here. There are different ways to do this, but this is what I like to do. I like to use the midpoint theorem when you're dealing with these 2 transformations specifically, because it takes care of both of them at the same time. So what I have here is I have NSP, which is your new start point, NEP, which is your new end point. Then you're going to have 3 angles in between those 2, just like in your parent graph of the sine function. So what I do is I take this right here, this binomial, and I set it equal to 0, because that's the start point for the sine function, and I solve for t. So now my new start point is pi over 4. Based upon these 2 transformations, the horizontal shift pi over 2 to the right, and the period shrink to pi. Then I go over here to my new endpoint. So I take that binomial. Let me do this. And this time I set it equal to 2 pi, since 2 pi is the original endpoint for the sine graph. And I solve for t, and I get 5 pi over 4. Now before we go on, you have pi over 4 and 5 pi over 4. So the distance between these 2, it is pi, and that's what it should be, because your length of your wound period is pi. So if you notice on the graph, here's your start point and here's your end point. Then you have to find 3 angles in between, just like in your regular sine graph. So before I said that I use the midpoint theorem, so here's where I'm going to use it. Now if I want to find the midpoint between these 2, my NSP and my NEP, what I do is I take these 2, I add them together, and then multiply by 1/2. So then the midpoint between those 2 is 3 pi over 4. So look at that. That's right smack the middle of these 2. Then I do the same thing to find the midpoint between these 2. So I add these 2 together, cut it in half, and I get pi over 2. Then lastly, to find the midpoint between these 2, I add these 2 up, multiply by 1/2, and then I get pi, and I put that there. Notice the order. I like to do this in order as I'm moving to the right. I have pi over 4, pi over 2, 3 pi over 4 pi, and 5 pi over 4. Just to make sure you don't get confused. So that's the same order as here. So when you do it this way, this is how you're going to list the angles on your horizontal. All right, now this whiteboard isn't very big, so I couldn't fit the work for the second period moving to the left, but I'll just tell you this. So your start point is going to be the same as you move to the right and to the left. Then you're going to have an angle of 0, negative pi over 4, negative pi over 2, and negative 3 pi over 4. Notice that the distance between these 2 is pi. That always has to match. And then you have 1, 2, 3 angles in between these 2. Right? So I'm going to show you the work of how to get these angles here. I'm going to use the midpoint, just like I did on that first period. So this time, because I'm moving to the left, my angles are going to be in order as I move to the left. So the new start point is the same. Now the new end point, I take that binomial in the original equation, I set equal to negative 2 pi, because this is the original end point for the sine graph on the left-hand side. I solve and I get negative 3 pi over 4. So then what that means is then in between these 2, I'm going to find 3 angles by finding the midpoint. So I take these 2, add them together, multiply by 1/2. So that midpoint is negative pi over 4. Okay, then to find the midpoint between these two, I add them up, multiply by 1/2. I get negative pi over 2. And then lastly, right here, I take the midpoint between these two. So I add these two up and multiply by 1/2, and I get 0. This time, like I said before, and you'll see on the graph, I'm going to show it again. I write these in this order because you're going to move going left. So it goes pi over 4, 0, negative pi over 4, negative pi over 2, negative 3 pi over 4. Because as you're moving this way, you're getting more negative. So this is the work to find the angles for that second period as you move to the left. So let me show you that. I'll go back here. And here's your new start point, your new end point. Then in between you have 0, negative pi over 4, negative pi over 2. Remember, the sine graph is an odd function, so it doesn't move the same way to the left as it does to the right. So from here it goes down to the lowest point, then you go through the horizontal high point, and then back down to the horizontal. Okay. Now this video you may have to watch a couple of times to get it. There's a lot more work involved. But once you get the hang of it, I think you'll find it easy. Just remember to find your angles. All you're doing is you're using the midpoint theorem. So that means you add two angles up and multiply by 1/2. I'm going to do another one giving you an example of cosine with these transformations here, just so you have that experience of viewing that. But if you have any questions on this, make sure that you email me and I will answer your questions either through email or another video. All right, take care, everybody.